Welcome to The Explainer. Today we are diving into one of the biggest questions in physics. I mean, a real head-scratcher. What gives the proton its mass? A fascinating new paper thinks it has an answer, and it's surprisingly simple. Let's break it down. Okay, so let's just put it right out there. What gives a proton its mass? You'd think that would be a pretty straightforward question, right? But nope. If you ask a physicist, they'll tell you this is one of the toughest nuts to crack in the entire field. It's not that we're totally in the dark. We know protons are the absolute heart of every atom. And the standard model has an explanation. It says most of the mass comes from this incredibly complicated dance of quarks and gluons whizzing around inside. But that's more of a how than a why. Trying to explain why it has that specific mass from scratch has just been this lingering, nagging mystery for decades. And this, right here, this is the perfect way to look at the problem. See, on the one hand, we can measure the proton's mass with just insane precision. We know what it is, down to the tiniest decimal point. But on the other hand, a clean theory that just explains why it's that number, that's been the real struggle. It's like we've got the answer, but we still can't figure out the question. All right, so here's our game plan for today. We're going to walk through the mystery, then check out this new cosmic blueprint. We'll see how it works, what it calculates, and then think about what it all could mean. Let's get into it. Okay, first up, the proton's mass mystery. See, what physicists are really hunting for is what they call a first principles answer. Basically, they don't want to just cook up a formula that spits out the right number. They want an explanation that comes straight from the universe's fundamental rulebook. No cheating, no fudging the numbers. Which brings us to a potential game changer. Let's talk about this new cosmic blueprint, the Harmonic Scale Framework, or HSF. Okay, now this is where things get really cool and kind of mind-bending. The HSS says, forget thinking about particles as tiny little billiard balls. Instead, picture them as vibrations, like a guitar string ringing out with a pure, stable note. The idea here is that the entire universe is a kind of cosmic symphony, and every particle is just a different note being played. So in this symphony, there are different channels that do different things. And there's this one special channel, they call it K4, or the neutral field, and its whole job is to be an energy depot. Think of it like a battery pack just for particles. And bam, this is the big idea. According to HSF, mass isn't something a particle is, it's something a particle has. Specifically, it's just the total amount of energy it's got stored away in that K4 depot. That's it. More energy stored, more mass. It's that simple. All right, the single anchor principle. So you might be thinking, okay, mass is stored energy, but how do you know how much energy to store for a proton? Well, that's where this really clever trick comes in. The whole logic is just beautifully simple. Check this out. Instead of a bunch of complicated math and variables, they say you only need one piece of information from the real world, one anchor. You take the proton's physical size, which we can measure, you use that number to set the energy level in the depot, and whatever energy value you get from that, well, that is the proton's mass. Done. And here it is. This is the key that unlocks the whole thing. The one and only number they need from an experiment is the proton's charge radius, its size. It's about 0.84 femtometers, which is just ridiculously, mind-bogglingly tiny. But the crucial part is, it's a real measurable number. And in this whole theory, it's the only starting point you need. So, let's unlock the proton's mass. The big question is, what happens when you plug that one little number into this HSF model? What answer does it spit out? The result? Well, it's pretty staggering. The paper puts it perfectly right here. The model gives you the proton mass with no free parameters. Now, what does that mean? Think of free parameters as little cheat codes or dials you can turn to fudge the math and make the answer fit. This model has none of those. The correct answer just falls out of the calculation all on its own. And this is why it's so compelling. It's not just about getting the right answer. It's the sheer elegance of it all. You've got one real-world measurement, no arbitrary tuning knobs, and it directly connects a particle's size to its mass. Oh, and as a bonus, the paper claims the same logic can derive the mass ratio between a proton and an electron. It's all just self-contained. Okay, so this is where we zoom out. If this harmonic idea works for the proton, what else could it do? Is this just a one-trick pony? Or could it be pointing to a universe built on harmonics? Well, the authors say it's definitely not a fluke. They ran some consistency checks. And they found that the same basic rules seem to line up with other things we know to be true, like the proton's magnetic moment and even the geometry needed to describe gravity in their model. It all seems to fit together. And what that really points to is a much deeper, more unified picture of the universe. I mean, if this is right, then things we always thought were separate concepts, a particle's mass, its size, even the force of gravity, they might not be separate at all. They could all just be different facets of one single underlying harmonic structure. So that leaves us with a pretty wild thought to chew on. If a proton's mass is really just a harmonic of its size, what else is out there? What other deep cosmic mysteries that seem impossibly complex right now are actually just waiting for us to discover the simple, elegant rule that's been hiding in plain sight all along?